Hello, I'm Seema and welcome to my channel. Today I'm talking to you from my kitchen, and the reason I popped in was that there was a doubt asked by one of the students and I wanted to answer it. The question that this child asked was that we know that our LPG cylinder contains liquid under pressure, but why it remains as a liquid at room temperature where LPG has a low boiling point? I felt it's a very interesting question, and I wanted to do a little demonstration to explain the answer to this. And let me repeat the question once more. We know that our LPG cylinder contains liquid under pressure. So if you know how the LPG cylinder is made, is that gas, petroleum gas, the molecules are forced into the cylinder, and so many molecules are forced into the cylinder that the molecules, they keep coming closer to each other. What is the difference between solids, liquids and gases? In the case of solids, the molecules are very close to each other. In liquids, the molecules, and in solids, they cannot move. The molecules cannot move. They are fixed in their positions. In a liquid, the molecules are touching each other, but they can slip and slide, they can move. That is why it's a liquid, but they are pretty much touching each other, the neighbors. And gases, the molecules are far apart. So what we do in the case of petroleum gas, we compress the gas, we force the gas to come into the cylinder, and we force so many molecules to come close to each other that they start slipping and sliding, they start touching each other, they start slipping and sliding over each other, and they start acting as a liquid. It is not a liquid at that temperature. It is not supposed to be. The moment you release, just as you open the can of a soda, like if you have Coke, the fizz, the gas has been pressurized into it, and the pressurized gas is stuck inside the can of soda. Like if I have, oh boy, yeah, I have this. So in this can of soda, if I try to unravel this, if I try to open it, there is gas which has been forced and pressurized and has been put into it, which is carbon dioxide. The moment you open a can of soda, you hear a fizz, don't you? Do you hear the fizz? It wasn't as much, but now I'll have to drink the Suncrest. Anyway, the gas that is trapped inside the cylinder, that gas is acting as a liquid. It is not actually a liquid. So imagine that I have this Nutella jar, and let us imagine that this is the gas. It's a sponge. It's a solid, very much a solid, but a sponge is a solid which has the air bubbles are gas which is trapped into it, air that is trapped into it. So when I compress a sponge, the air gets compressed, right? So when I compress the sponge, let me try and put it in this little jar. The sponge was really big, but I'm squeezing it and I'm squeezing it and I'm pressurizing it and I'm putting it in this little jar. And I closed it, right? Now, in this, it is acting as a solid, as if there is no air in it because the air has been compressed. If I took the petroleum gas and I compressed it and I put it in the cylinder, it would be acting as a liquid. It is only acting as a liquid. The moment I open the jar, the sponge starts trying to pop out. And the moment I take the sponge out, you see, whatever little bit has been pulled out has expanded. And as I keep pulling it out, as I keep pulling the sponge out, do you see? It expanded further and it went back to its original shape. So it went back to being what it was, the spongy solid, which has air filled up in the air gaps. The same thing happens with LPG. The cylinder has got molecules which are compressed together, pushed together so that they slip and slide over each other. They act as a liquid. But the moment you turn your gas on, do you hear the sound of gas coming out? Just as you heard the fizz coming out of a drink. The gas which was compressed and was acting acting as a liquid. The moment you open the gas tap, it starts coming out in the form of a gas again. And that is what happens. That is the reason why, what was the question? The LPG that was there. What's wrong? Okay. Yeah, that cancel. We know that our LPG cylinder contains liquid under pressure. It is liquid, but it is a liquid under pressure. It's not a true liquid. But why it remains as a liquid at room temperature? Because even at room temperature, it is going to act as a liquid as long as it is trapped inside the cylinder. As long as this was trapped inside the cylinder, it acted as a liquid. The moment you release it, the liquid, it is actually supposed to be a gas at that temperature. Therefore, the moment you turn the gas on, it is not liquid that comes out of it. It is gas which comes out. Because the moment you release the pressure and it comes to atmospheric pressure, it turns into a gas, which it naturally is. So this is the answer to your question. I hope it satisfies your curiosity. Thank you for watching, and bye-bye for now.